You've probably already heard the term big data, but what is it really? And what are its implications? In this unit, you will learn about all of that, and we'll start with a basic introduction to the topic. Let's start off the lesson by just trying to understand what exactly that is. The Wikipedia definition is on the screen here, and it says a collection of data sets so large and complex that it becomes difficult to process using standard techniques. Okay, and we have another little fun fact here that as of 2012, every day 2.5 quintillion bytes of data are created. Not processed, but actually created. All right, and when you stop to think about it and you realize that if you have a byte of data, you need 8 bits of physical storage to store that data. All right, so this is a quintillion bytes of data. That number of bytes times 8 bits means we need that amount of circuits to store this amount of data. And that's being created every single day. So that's kind of mind-boggling. So where does the data come from? Well, we'll talk about that in a second, but just some food for thought here. If you think about all of the stuff going on right now with DNA testing, right? You can do Ancestry, you can do 23andMe, you can do MyHeritage, and all these different types of DNA testing services. So originally, now the reason we can do this is because someone took the time to decode the human genome, right? And the entire human genome originally took a decade to process, 10 years to figure out, to break down the human genome into its individual parts. At this point, you can spit in a tube and send it off. And of course, you got some red tape and some, bureaucracy to slow you down, but you can really have results in like a week. Okay, so what took 10 years originally can now be achieved in 1 week, which is kind of crazy. Think about the amount of pictures that are uploaded to social media sites like Facebook, for example, because they've been in the news a lot lately. They handle 40 billion photos from its user base. All right, so just 40 billion photos. So that's just kind of to get you started on why we don't just talk about data, we talk about big data. So to get a little bit more specific about where the data comes from, like how is it collected? Like where do we get it? One way that this happens is with what's referred to as radio frequency identification. All right, and that's what you can see on the screen there. RFID tags, physical tags, enable objects to be tracked. All right, and the objects can be tracked using radio waves, okay, which are really low power. We've been using radio waves for a really, really long time, longer than we've been using computers. And so radio waves are a pretty low power way to be able to track these things. In the lesson, or in this picture, as a matter of fact, you can see these things, they're actually used to track inventory. Other things that you could track would be like encoding personal information in something like a speed pass, or what we have here in Florida on our toll roads is a sun pass. You could potentially be broadcasting data and not even be aware that you're doing it, which is kind of crazy. How do you think they can tell when you've shoplifted? They've got those tags on there to prevent, and they have to remove them before you can walk out of the store with them. So how is the data actually created? We said all this data is being created every single day. So how? Almost everything that we do is stored digitally, right? And you've probably heard about reducing your digital footprint. Like how much of your personal information is available online and how much people can learn about you from tracking your digital activities, right? That's your digital footprint. And data is everywhere. Like fingerprints or footprints, we literally leave them everywhere we go, okay? Even if that is in the digital world. So for example, in the past, stores would keep track of prices and their inventory so that they could know what they had to purchase, and they would know how much money they were making, right? And so that kind of stuff was tracked. But now, not only are they tracking what the price is and how much of that thing they're selling, but they're keeping track of so much more, right? So you can see from this receipt for Walmart, literally almost to the second, when you were in Walmart, you can tell exactly what you bought, exactly how much it cost, how you paid for, all kinds of things. So Walmart is keeping track of a whole lot of data every time someone makes a purchase. And that requires massive computing power to process all of that data. So that brings about the question, if we need physical space or memory to store all of this data, and we have these massive quantities of it, where do we put it? Some data sets for like very large companies or people who are doing a lot of research, some of those data sets are large enough to require like an entire building devoted just to housing those computers, to store it in addition to processing it. Some people estimate that each of Google's data centers, each of which is huge, by the way, contain nearly 1 million individual servers. All right, just imagine that. You're looking at 100 plus servers just in this picture. So imagine how much space would be taken up by 1 million in just one of Google's data centers. So that's crazy. So big data is, it's one of the big ideas for AP CSP, and you're going to need a framework for understanding what big data is and why it's so important and what you need to learn about it, right? So the things that you need to understand about data, first of all, it's important to know how the data is collected. So first you want to know how that data is collected, all right? Then you need to know, well then, if all this information is collected, how do we extract the information that we want? Right? That's something to understand. It's also important to understand, how is that data stored? Where is it stored? Is it secure? Who can access it? These are questions that you want to ask. And finally, you need to be able to analyze the data in order to make meaningful conclusions, right? You can track all kinds of things and store the results in a database, but until you actually sift through that data and analyze it, you won't really understand what it means, and you won't be able to do anything meaningful with it. So the data exists somewhere. It's our job to make sense of it. All right, so in the picture, you can see some traditional sort of methods of collecting data. We've got the beakers, we can see the measurement, a digital collection of something, a stopwatch. So these are traditional, maybe we want to call these analog types of data collection, because to be able to use data, we have to collect and analyze it, right, to make a meaningful conclusion. So let's talk a little bit more about how this is done. All right, so there are a lot of ways to collect data. Primarily, we're concerned with converting either an actual experience or some sort of phenomenon, natural phenomenon. For example, think about the receipt that we looked at. Somebody went to Walmart at 3 o'clock in the morning and bought pickles and ice cream. Huh. What does that make us think? All right. What we need to do is we need to convert that data into a digital format, okay, that person's experience of being at Walmart at 3 o'clock in the morning and what they bought. We have to convert that into some sort of digital format in order for us to be able to process this computationally. All right, and so everything on that receipt was up for grabs digitally. Whoever issued the receipt now can go back in wherever that's stored and look at all of that data and access all of that data, not just from that one particular customer, but maybe from all of the customers. Hopefully there weren't that many of them there at 3 o'clock in the morning, but all of them, between the hours of 2 a.m. and 3:30, and to try and draw some sort of conclusion about what were those people doing there? What were they buying? And why did they need to buy it at 3 o'clock in the morning? And that could help them. That could, potentially allow them to cater to those particular types of customers, right? So if you think about Google searches, Facebook posts, smartphone apps that have, for example, your GPS or a seismometer, and traffic of websites, how many visits a particular website has. That's important for that company to know. All right, so technology-based data collection is where we use a particular algorithm to track, copy, and tabulate, and then further process the data samples that we get. You get a big chunk of data. It doesn't mean anything until it has been analyzed. We can't really know anything other than really the basic level of what that data shows us. Yes, it shows us what they bought and what time they bought it, right? But that doesn't lead us to any meaningful conclusion. So we're talking about the extraction of knowledge from the data. How can we pull out meaning from the data? All right, so it's primarily concerned with taking the information, in this case from the receipt, and deriving basic facts or some sort of structure from it, right? So we could get all of the receipts collected from a certain amount of time, and we can isolate each transaction and describe it in terms of when did it happen, where, which stores, the ID of the transaction, and any other associated transactions, like returns or something like that, right? So we could pull out those particular pieces of information from multiple receipts. And that data is the data that would be put into a database, a software program that allows you to enter data and to have it saved in a structured format. So here's an example of what it might look like when you look at a database, at least a traditional relational type of database. It will look like a spreadsheet. You've seen spreadsheets before, and it kind of looks like that. But what a database is good at doing is finding relationships between the different, like say, the different records that are shown. We store the digital information in a database, and we can save it. You can see that it can accumulate over time, so we can aggregate the data, and then once we feel like we have enough, not immediately, because you really can't draw anything meaningful from just a few samples, but once there is enough of it, then later on we can analyze it. So just like anything, not just talking about data, but talking about life in general, the ability to analyze, to really think critically about something and to isolate patterns and relationships and correlations, it's a really important skill. And it becomes even more important when we're talking about data. All right, so making predictions or describing trends based on data assumes that, number one, the data to support the prediction does exist. Like, you haven't just completely pulled this prediction out of thin air as a guess. You are basing the prediction on a significant amount of data that leads you to believe what is going to happen next. All right? And secondly, you need knowledge, right? You have to be able to make inferences and kind of read between the lines in that data. All right, so if we're still talking about our receipt, the issuer of the receipt, Walmart, might hope that in gathering all this data, they would be able to make a prediction about certain customers might want to purchase in the future, right? And so if they see a trend in people purchasing a certain thing, they'll know that their inventory needs to be replaced very soon. And maybe they can charge a little more too. Or maybe they could actually be nice and put it on sale since a lot of people are buying it, but that we know that won't happen, right? So there's an emphasis on data analysis, on pulling knowledge, right? Knowledge discovery. So on the screen, we're kind of moving away from pickles and ice cream, and now we're looking at salt and pepper. Maybe there is a certain store and they're tracking purchases of salt and pepper. And so they're starting to notice a correlation between customers who buy pepper and salt purchases. And they're finding that it seems like anytime a customer purchases pepper, that they also purchase salt. But When they look at people who purchased salt, not all of them purchased pepper. Okay, so think about that and what that might tell you, what knowledge you can extract from that information. In looking, hopefully you have enough data to prove not just like 2 or 3 people, but a substantial amount of data to support this. And it might start leading you towards ideas. Maybe we just like salt better than pepper. Maybe we as Americans consume too much salt. Maybe people who purchase salt use it for cooking. Maybe they're using it to make a homemade Play-Doh. Do you know you could do that? You can do that. Or maybe black pepper is purchased by a particular subset of people, like people who cook a particular type of ethnic food, which requires pepper. You really have to think about facts and data and patterns. And really, if it was really important to find out the answer, then you might want to think about, well, what other data might I need to start figuring this out? For the rest of this lesson, you will get to learn about the origins of big data, the power that can be wielded by people who are able to use and process big data, and the unfortunate downside. You probably already have some ideas on what that can be from things that have been happening in the news with data breaches with big companies, right? So there's also a chapter of Blown to Bits, the book, that is linked as well. That is a really good read. It'll help you give a context to what we're talking about.
Big data is an elusive concept. It represents an amount of digital information which is uncomfortable to store, transport, or analyze. Big data is so voluminous that it overwhelms the technologies of the day and challenges us to create the next generation of data storage tools and techniques. So big data isn't new. In fact, physicists at CERN have been wrangling with the challenge of their ever-expanding big data for decades. 50 years ago, CERN's data could be stored in a single computer. Okay, so it wasn't your usual computer, this was a mainframe computer that filled an entire building. To analyze the data, physicists from around the world travelled to CERN to connect to the enormous machine. In the 1970s, our ever-growing big data was distributed across different sets of computers which mushroomed at CERN. Each set was joined together in dedicated home-grid networks. But physicists collaborated without regard for the boundaries between sets, hence needed to access data on all of these. So we bridged the independent networks together in our own CERNnet. In the 1980s, islands of similar networks speaking different dialects sprung up all over Europe and the States, making remote access possible but tortuous. To make it easy for our physicists across the world to access the ever-expanding big data stored at CERN without travelling, the networks needed to be talking with the same language. We adopted the fledgling internetworking standard from the States, followed by the rest of Europe, and we established the principal link at CERN between Europe and the States in 1989, and the truly global internet took off. Physicists could easily then access the terabytes of big data remotely from around the world, generate results, and write papers in their home institutes. Then they wanted to share the findings with all their colleagues. To make this information sharing easy, we created the web in the early 1990s. Physicists no longer needed to know where the information was stored in order to find it and access it on the web, an idea which caught on across the world and has transformed the way we communicate in our daily lives. During the early 2000s, the continued growth of our big data outstripped our capability to analyse it at CERN, despite having buildings full of computers. We had to start distributing the petabytes of data to our collaborating partners in order to employ local computing and storage at hundreds of different institutes. In order to orchestrate these interconnected resources with their diverse technologies, we developed a computing grid enabling the seamless sharing of computing resources around the globe. This relies on trust relationships and mutual exchange. But this grid model could not be transferred out of our communities so easily, where not everyone has resources to share, nor could companies be expected to have the same level of trust. Instead, an alternative, more business-like approach for accessing on-demand resources has been flourishing recently, called cloud computing, which other communities are now exploiting to analyse their big data. It might seem paradoxical for a place like CERN, a lab focused on the study of the unimaginably small building blocks of matter, to be the source of something as big as big data. But the way we study the fundamental particles, as well as the forces by which they interact, involves creating them fleetingly colliding protons in our accelerators and capturing a trace of them as they zoom off near light speed. To see those traces, our detector, with 150 million sensors, acts like a really massive 3D camera, taking a picture of each collision event at up to 40 million times per second. That makes a lot of data. But if big data has been around for so long, why do we suddenly keep hearing about it now? Well, as the old metaphor explains, the whole is greater than the sum of its parts, and it is no longer just science that is exploiting this. The fact that we can derive more knowledge by joining related information together and spotting correlations can inform and enrich numerous aspects of everyday life, either in real time, such as traffic or financial conditions, in short-term evolutions, such as medical or meteorological, or in predictive situations, such as business, crime, or disease trends. Virtually every field is turning to gathering big data, with mobile sensor networks spanning the globe, cameras on the ground and in the air, archives storing information published on the web, and loggers capturing the activities of Internet citizens the world over. The challenge is on to invent new tools and techniques to mine these vast stores, to inform decision-making, to improve medical diagnosis, and otherwise to answer needs and desires of tomorrow's society in ways that are unimagined today.